Hello everyone. Today let us see or discuss about recursion. So what is recursion? Recursion is nothing but just looping. Okay, looping of a statement or a code repeatedly. Repeatedly. Okay. Now let us take an example. Factorial. What is factorial? So for example, if I give 4 factorial, if I want to find a 4 factorial, simple 4 into 3 into 2 into 1, right? So 4 into 3, 12. 12 into 2 into 1. That is simple. 24, right? 24 into 1 equal to 24. So answer of 4 factorial is 24. Similarly, what is the factorial of 3? Simple 3 into 2. 3 into 2, 6. So what is the 5 factorial? 5 into 4 into, of course, it is 2 into 1 equal to 0. Okay, equal to 6. 5 into 4 into 3 into 2 into 1. So let us compute from left to right. Okay, 5 into 4, 5 into 4, 20. 20 into 3 into 2 into 1. Okay, 20 into 3, 60. 60 into 2 into 1 is 60 into 2, 120 into 1. Sorry, 120 into 1 equal to 120. So factorial of 5 is 120. So let us see a problem. The problem statement is very simple. What is the factorial of n? Okay, given n, to find the factorial. That is the problem statement. When you see algorithmically, okay, algorithm, it is about solving the function, right? Whenever you want to solve a function, okay, in a recursion, the first step is to find exit condition. For example, in this problem, what is the exit function? Whenever you find a value 4 factorial, so first we found 4 into 3 into 2 into 1, right? So 4 into 3, 12. 12 into 2, 24. 24 into 1, 24, right? So in this year also, what is the 3 factorial? 3 into 2, 6. 6 into 1 equal to 6. Here, 5 into 4 into 3 into 5 into 4, 20. 20 into 3, 60. 60 into 2, 120. 120 into 1 is 120, right? So what is the exit condition? Whenever it reaches 1, right, the function should exit. To find the exit for this problem, what is the exit condition? Whenever it reaches 1, then it should exit, right? So let us write a condition if, right, n, okay, n reaches 1, then we should return. If n equal to 1, then we'll return n itself, right? Otherwise, otherwise what we have to do is we have to see 3 into 2. For example, n equal to 3, then what we have to do is we have to multiply, right? So n into n minus 1, right? Then that's all right. For 3 factorial, 3 into 2. So n equal to 3. So 3 into 3 minus 1. What is that? 3 into 2, right? So again, we found the answer 6. What is the exit condition? Again, into 1, right? That is n minus 2. n minus 2 into n minus 2 into n minus 2. So what happens? So what is n? 3. 3 minus 2 is 1. So it is 1, I mean 12 into 1, right? Whenever n equal to 1, it returns n itself. That is 1. It will return 1. That is 12. So if condition is, I'll use different color. If n equal to 1, then it will return n, right? Otherwise, else, what we have to do? Yes, return n into n minus 1. It is a function, right? It is a repetitive function. It is a function of some, okay, I'll put f function, okay, function of, what is that? N minus 1. Exactly. So this is the algorithm. Let me create one more, right? So let us write an algorithm. Let me put, what is the input? Input is n. Okay, n can be any positive number. Okay, or it can be 0, or it can be 0 also. 0 also. Okay, so let us see how to handle 0. Okay, what is 0 factorial? Equal to 1, right? Let us see, later we can find a solution for 0 factorial, right? Now write a function, input is n, right? uh, Let me put def, okay, factorial, we are passing n. All right, so what is the condition? If n double equal to 0, we have put input should be positive number, or it can also be a 0, right? If n equal to 0, then we will be returning 1. 0 factorial is 1. Else if, okay, else if n is greater than 0, okay, then what we have to return? If greater than 0, or we can write a condition. Sorry, what is the condition? That if n equal to 1, this is the exit condition, right? A function can have a multiple exit condition. This is one exit condition, another exit condition. If n double equal to 1, then we'll be returning n itself, because n equal to 1, we're returning 1 itself. Else what we are going to return? Return, we have to multiply n into fact of n minus 1. That's all, right? Let us try to create a tree. Okay, tree for factorial. Okay, let us see. Let us write this function. Okay, def fact n. If n double equal to 0, then we will be returning 1. Else if n equal to 1, then we will be return n itself, right? Else if, I don't want to if condition, just we can put else return n into fact of n minus 1. We can also simplify this equation, right? How to simplify this equation? I mean, to simplify this algorithm, fact of n, if n double equal to 0, or, right, if n double equal to 1, will be returning, here it is 1, sorry, okay, 1, right? Return 1, okay? Else return n into fact of n minus 1. right? So this is the function. Let us draw the tree, okay? Tree for this particular function. Def fact of n if n equal to 0 or n equal to 1 will be returning 1, or return fact of, sorry, control Z, n into fact of n minus 1. So this is the algorithm, okay? This is the algorithm. We can draw the tree. For example, if we pass 3, okay? If n equal to 3, let me optimize this screen, okay? Let us see n equal to 3. If you pass 3, what happens? What happens? It is not 0, no? This function fails, right? This condition fails. Then it will come over here. What is n? That is 3, okay? 3 into, okay, fact of n, 3 minus 1, that is 2, okay? So again it will call, 2 will be passed over here, right? 2 will be passed over here. So again this condition fails. Again this condition fails. Then 2 into fact of 2 minus 1, okay? That is nothing but 1, okay? I'll use different color. So again passing 1, passing 1. If you pass 1, what happens? This condition satisfies. It will return n equal to 1 equal to 1. So it will return 1, okay? So we can back trace it, trace it. I'll use it, okay? So 1 into 2, 1 into 2 equal to 2. 2 will be written over here, okay? 2 into 3 equal to 6. 6 will be written to the main function, the calling function, okay? So answer will be 6 for 3 factorial. Let us assume n equal to 4. So first you will be calling function, right? Control Z. Let me call a function of fact of 4. I'll be passing here, right? So what we'll get? It condition fails. So 4 into fact of 3. Okay. So again condition fails. 3 into fact of 2. Again condition fails. The exit condition fails. Okay. Then 2 into fact of 2 minus 1 is 1, okay? Whenever you pass 1 or 0, okay, so it will return 1, right? So 2 into 1, 2, 2 into 3, 6, okay? 6 into 4, 6 into 4, 6 into 4, 24, okay? N factorial, I mean that is 4 factorial equal to 24. Am I right? Yes. So how many functions are called? 1, 2, 3, 4. 4 functions are called, right? Let us take n equal to 5. Fact of 5. So 5 into fact of 4, right? 5 minus 1. So 4 into fact of 3. 3 into fact of 2. So 2 into fact of 1, right? So 1 into 2, 2. 2 into 3, 2 into 3, 6. 6 into 4, 24. Okay, 24 into 5, 24 into 5, 120. Yeah, 120, right? So 5 factor equal to 120. Okay. So here, let us find a time complexity. Whenever you write an algorithm, you have to define the complexity. One is space or and time. Okay. Don't worry about space as of now. I'll take a different class for space complexity to find the type space complexity. As of now, we can estimate time complexity. Let us start with okay, n. How many functions are called? 1, 2. When n equal to 3, how many functions are called? 1, 2. Let us assume 2 functions are called times. Okay. When n equal to 4, how many functions are called? Okay. So we will be passing, right? 1, 2, 3. Okay. 1, 2, 3. When n equal to 5, 1, 2, 3, 4. Okay. 4 functions are called, right? Let us try to estimate for n equal to 6. So n equal to 6. So what happens? 6 will be fact of 6, right? So whenever passed, so 6 into fact of 5. Okay. So 5 into fact of 4. 4 into fact of um, 3. 3 into fact of 2. 2 into fact of 1, right? 1, 2, 3, 4, 5. N equal to 6. It calls 5 times. Okay, I think this pattern you can find the pattern and easily you can estimate. For 7, 6 times it will be called. So let us assume the graph n and times. It can be units. It can be anything, seconds or minutes, maybe microseconds or milliseconds. So we define it as unit. So when equal to 3, you will be getting like no 2 times, right? 2, 3. Whenever 4, basically it will be a linear line. Okay, it will be a linear function. Now let us get into the programming part. Let me write a program using Python programming. Okay, Python language. Uh, it is a factorial. What will be passing? Will be passing n. So what is the exit condition? N equal to 0 or n equal to 1. Then it should return 1, or it should return n into fact of n minus 1. Let me call the function fact of 3. Okay, save. Uh, Let me put f equal to and print f. I think this saves. Let me execute Python recursion. Yeah. So let me pass 4, 24, right? When you pass 5, it is 120. Okay. For the matter of fact, you can find number of times this function has been called. I'll put just maybe I'll tell number of times, right? Hello, checking number of times. Let us compute for 3. How many times it has? Okay, 1, 2, 3 times. Okay, let us do for 4. Okay, it takes 4 times. Okay, let us take 5. 5 times. So, okay, of course, there is a difference. I told that the number of 3 equal to 2 times. Basically, I ignore this function, factorial of 1, right? Again, it will call. So, that's the fact. Hope you understood. Anyway, whenever even it is a, it is 3 or 4 or 5 or 6 or 7, it is going to be a linear functions. So you can easily write a time function t of n equal to maybe n minus 1, but actual program gives n equal to n. Okay. For example, t of 1 will return, let us assume n, so 1. T of 2 equal to 2. T of 3 equal to 3. Okay. So this is the time complexity. So order of n equal to, in the worst case, it will return n. Okay. Thank you everyone. Hope you understand.